Hey, what's up, guys? This is Hone here, and today we're going to go over MergeSort. And this tutorial is going to kind of assume that you know a little bit about programming. We're going to use Python in particular. I'm just going to kind of jump right into it. We're going to go over the recursive implementation of the algorithm and then use some debugging tools to kind of show you how it works, how the recursion works, how things are called to the stack, and everything like that. So. I'm just going to start it out, and we're going to define a merge function, and it's going to take a left and a right array, or the split halves of the array, and then what it's going to do with each half is we're going to have an index for the left array, and we're going to have an index for the right array. All right, oops, index for the right array, and then we're going to have a resulting array. This is what our return is going to be, and we're going to append we're going to compare the left element and the right element, the first one of each array, and then we're going to append the smaller one of the two. So to do that, we just say while I is less than the length of the left and j is less than the length of the right, we are going to check and see if the element in the, oh, this needs an and, I'm an idiot. There we go. So we're going to have to check here and see if the element in the left array is smaller than the element that we're comparing in the right array. Now, if that's the case, we'd want to append that smaller element, which was the left side of I, to the result. And then we're going to want to increment I by 1. Now, we're going, if right was smaller than left, we're going to want to append the right side. Boop, 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 boop. Append the right of j. All right, there we go. And then we're going to want to do j plus equals 1. And at this point, we may have gotten through the left side, and let's say there were still elements remaining in the right. It's going to break out of this loop, and we're going to have to append the remaining elements of the whichever array has elements remaining. So we're going to just want to check for both of them. We're going to say we're going to do the left of I through the end, and we'll add also the right of j through the end. Now let's say right was a length 1 and j was 1. This is going to return an empty array. So when it appends it, if we've already exhausted all the elements in the right array, when it does this, it's not going to add anything else. So at that point, we should have a sorted array in our result. Now, to use the merge, we're going to have to take in our original array that we're trying to sort, right? And we're going to have to split that in half and then feed in the left half and the right half into merge. All right, so we're going to define merge sort, and that's going to take an array. First, we're going to want to check and see if the length of the array is less than 2. If that's the case, we just return the array. Now, if it's greater than 2, we're going to want to split the array up into a left and a right half and call MergeSort on each of those halves. And we're going to keep doing that until we return an array that only contains one element. So we'll set a midpoint to the length of the array, floor divided by 2. Now this is floor division so that we can round it down. Let's say it was length of 7 on the array. It'll round it down to 3. Now we're going to set a left to the array, and we're going to slice that from the beginning to the midpoint. That's the left half. And then the right half is going to be the array split from the midpoint all the way to the end. And at that point, oh, I'm sorry, like I said, we have to call MergeSort on both halves of this, the left and the right half. MergeSort, there we go. And then at that point, we can return a merge of the left and the right. So that should be MergeSort. It's not too long. Let's see here, 24 lines of code, 23, something like that. So what we're going to want to do is I'm going to put a breakpoint here so that as soon as we enter our merge sort function, it's going to stop the code and we can just kind of go through it step by step and see how it's working. I'm just going to make an array. We'll make it of length 5, 1, 2, 3, 4, 5. All right, that should do it. Let's run this code. All right, so you can see it stops here. So merge sort's been defined. Array, all of our variables are going to be up here. So this is a good thing to know when you're using debugging tools. You're going to have your variables up here. You got your call stack right here. For this recursive implementation, the call stack is going to be important because you can see we have one merge sort on the stack right now, okay? But when we get here to left, it's going to put another merge sort on the stack, and then we'll be within that call, and we'll probably add another merge sort to the stack at that time. So here we go. Let's just go through it, and I'll show you what I'm talking about. So we're going to set the midpoint here to 2 because 5, 4 divided by 2 is going to be 2. You can see mid appears here right after I run over that line. So after I go over left, we're going to go back into merge sort. So it's going to go back up here again. It's going to check if the length of the left half of the array. The left half of the array is just 5 and 3. Okay, so watch. We're going to go next. The array is 5, 3. All right, it's going to say, oh, that's not less than 2. So we're going to split that in half again. So, and you can see another merge sort's been called to the stack. You can even click here and see where our original call of merge sort left off on left. Okay, so we can go back up here and we can go through it. You can set the mid again. This time it's going to be 1 and it'll split it in half. It'll do a left. Now it's going to go back into merge sort again, but this time, so we're going to add one more to the stack here, but it's going to return an array that only contains 5. And then it'll get taken off the stack, and then left on this level right here will be equal to 5. So let's go do that. One merge sort's been added to the stack here. Array is equal to 5. We're going to go through. Now that merge has been taken off of the stack, and the returned array that only contains 5 is equal to the left. You can see here, left is equal to 5. So now it's going to do the same thing. It's going to return an array only containing 3 to the right. There it is. And then it's going to merge those two together. So now it's calling merge. Merge will be added to the stack here. There we go. And now this is where we're setting our little pointers. We got our set our result array. Excuse me, sorry. Too much coffee. Not enough coffee. Woo. Okay, so here we're checking to see if this 5 is less than 3. It is not, so it's going to go to the else statement. It's going to append the 3 to our result array here. You can see that happen right there, and then we're going to increment j by 1. Now this is going to break out of this loop like I was telling you before, and it's going to go and append the remaining elements that are in the the left array, which is just 5, and then it's going to try and do the same thing for the right, which there are no elements remaining. So you can see it's going to append 5, and then try and append something else. There's going to be nothing there, and it's going to return the result, which is going to put us back here on this line. So boom, there we go. Returns the result, takes merge off the stack. And then now all we've done at this point is set the left half of the array on this level here to 3, 5, a sorted 3, 5. So check it out. Left is now sorted 3, 5, and we're going to go into the right half and we're going to sort that. Same exact thing. We got 7, 1, 9. We got one call added to the stack here. And you can see that original one, we finally made it to right. We're no longer on left. So we're doing the right side now. Here we go, mid, set the left half to 7, 1, or excuse me, just 7. The right half is going to be 1, 9. So it's going to return the left as just the array containing 7. And then now it's going to do the right side. But for the right side, it's going to create a left and a right, the left containing 1 and the right containing 9. It'll merge those together. Then it'll compare 7 against 1, 9. Okay? So here we go. It's got some longer than 1. So it's going to make left is going to be equal to 1. Return that. Right is going to be equal to the array containing 9. Return that. All right. Now we're going to merge that 1 and the 9 together. There we go. So, and then it returns that result. Boom. So now we have the sorted 1, 9, and we have the 7. All right, so let's go one more. 7, 1, 9, and it's going to merge those two together. All right, and then that, like I said, we're still on the right from our first call to the stack, our first call to merge sort. So after we get through this first call, then we'll go to merge and we'll merge the 1, 7, 9 with the 3 and the 5. Let's go back to where we are. Do this merge here of 7 and 1 and 9. So same. It's just going to go through and you can see what's happening here as things get appended. So we're going to go and append the element from the left array at increment 1. Now it sees that the counter for the left array was the same length as the left array, so it's going to go ahead and append whatever's remaining. There we go, and it appends that, returns the result, and now we have one more step. There we go. So now we have left 3, 5 and right 1, 7, 9. We're on our original call to merge sort, and it's going to merge those two together. This should be our final merge. So this is just going to go through exactly the same, except there's a couple more elements. So you can kind of watch the side there if you like as I step through it. I'm not going to explain much more here because it's pretty much the same exact thing. It's just comparing elements and appending the smaller element to the result. And then it finally is going to return us that value. And we get 1, 3, 5, 9, 7. All sorted in the bottom there. Finally done. So, I need more coffee. Yeah, that is MergeSort. That's how it works. I know sometimes going through the code, just typing it out and running it doesn't really stick, at least for me. So I like to do things like this, like adding breakpoints and kind of just walking through the code and seeing visually what's going on. So you don't have to just, store it all in your mind or write it all down. I'm not one of those people that likes to write everything down. So yeah, if you're having a hard time kind of visualizing what's going on with your code, make sure that you utilize your debugger tools, breakpoints, things like that. All right, well, thanks for watching, guys. If you want to see more of this kind of stuff, then make sure that you subscribe, hit the like button, all that good stuff. Kind of would get me motivated to put more content out there. As you can see, I'm just getting the channel started right now, so any support would be appreciated. Anyway, thanks again, guys. Have a good one.